Let's start with a feeling I think almost everyone has had at some point.
Okay.
You're scrolling through your phone, or you're reading the news, or maybe you're in a meeting that's just been going on for hours, and you get this profound sense of unreality. Like, is any of this actually landing? Is anything permanent here? Or is it all just noise that's going to evaporate the second I, close the tab?
It's the modern condition, isn't it?
Yeah.
We are drowning in data, but we are starving for reality, for something that feels solid.
Exactly. And we usually treat that as like a psychological problem. We say, oh, I'm just burnt out, or I need a digital detox.
Right.
But the document we are diving into today suggests something way, way more radical. It suggests this feeling of glitchiness, of things not feeling real, is actually an architectural problem.
It's a fascinating take. I mean, we're looking at a dissertation titled Noetherian Ontology and the Architecture of StrataOS.
Which I have to say sounds like a mouthful.
And I know. That title sounds like it was generated by a random word machine in a physics lab. It's dense.
It sounds terrifying, honestly.
It is dense, sure. But at its heart, it's asking really the oldest question in the book. How do we get from nothing, or more accurately, from infinite possibility to something?
To something that sticks.
To something that sticks.
Yeah.
How do we build a reality or a system that doesn't just fall apart into noise?
And the twist, and this is why I'm actually so excited about this one, is that the author claims this isn't just philosophy, it's not just a thought experiment.
No, not at all.
You can actually code it. They're proposing a whole operating system, StrataOS, that is built on what they claim are the exact same laws that create the physical universe.
So for this deep dive, we're going to be jumping between, high-level metaphysics and some very, very specific software engineering.
Okay, so where do we even begin with something that big?
Right. Well, to understand the software, we have to start with the physics. We have to start with the void.
The void. Now, usually when I think of a void, I think of empty space. Darkness, nothingness.
That's the intuitive view, is what we all think of. But in physics, and specifically in quantum mechanics, the void isn't empty at all. It's what's called a Hilbert space.
Okay, hold on. You dropped a term, Hilbert space. You're going to have to unpack that one for us before we can move on.
Of course. Think of it as a space of infinite dimensions. It's a state of perfect superposition.
Okay.
The best analogy I've heard is to imagine a library. But this library contains every book that has ever been written, every book that could be written, and every book that will never be written.
Wow.
And they're all existing at the exact same moment, all occupying the exact same space.
So it's not empty. It's too full, overstuffed.
Exactly. It's completely paralyzed by its own potential. If everything is possible, then nothing is actual.
Because it all cancels out.
It's a state of perfect symmetry. Everything cancels everything else out. And this is the starting point of the document we're looking at. The void is a chaotic soup of infinite possibility.
Okay, so we have this paralyzed infinite soup. So the central mystery of this deep dive then is, how do we get from that, where everything is happening at once and nothing is happening at all, to this?
Right.
To me, sitting here talking to you with a specific time on the clock and this coffee cup that is definitely here on my desk and not, on Mars.
The transition from potential to actual.
Yeah.
That's what the source calls the paradox of existence.
And it claims that observation is the key to solving it. But I want to be really careful here because observation creates reality is a phrase that gets thrown around a lot in, let's say, less than scientific circles.
Right. The secret version of quantum physics.
Exactly. It sounds like magic. I look at the parking spot and it just appears. That's not what we're talking about, is it?
No, this is not that. This document is trying to ground that idea in hard structural rules.
Nah.
It argues that for a universe, or for a secure operating system to function, observation isn't a passive act. It's an active symmetry-breaking event.
Okay, symmetry breaking. That feels like a key phrase. And it leads us to the hero of our story today, a physicist named Emmy Noether.
Yes.
Now, I'll be honest, I knew the name, but I did not realize how big of a deal she was.
Oh, she's arguably one of the most important mathematicians of the 20th century. I mean, her work is fundamental to understanding the very structure of the universe. Einstein was a massive fan.
So what was her big idea?
Her core contribution, Noether's theorem, basically runs all of modern physics.
So let's do the Physics 101 version. What is Noether's theorem? Can you break it down?
In simple terms, for every continuous symmetry you find in a physical system, there's a corresponding conservation law.
Okay, I'm going to stop you there. I think I need a metaphor. Continuous symmetry and conservation law. What does that mean in the real world?
Okay, let's imagine a spinning top. It has rotational symmetry.
Meaning you can look at it from different angles and it still looks like a spinning top.
Exactly. The laws of physics acting on it don't change just because you turned your head 40 degrees to the left. The rules are the same regardless of your viewing angle.
Okay, that makes sense.
Because that symmetry exists. Because the rules don't care about the angle. The universe has to preserve a quantity. In this case, it's called angular momentum.
And that's the thing that keeps the top upright while it's spinning.
That's why it stays upright. It's conserved. The symmetry forces something to be saved.
So because the laws are symmetrical, something like energy or momentum is saved or conserved.
Precisely. Or take time. The laws of physics are the same today as they were yesterday and as they will be tomorrow. That's a symmetry across time.
Time symmetry.
And because of that symmetry, we get the conservation of energy. It's the reason energy can't be created or destroyed, only changed from one form to another.
Okay, I'm with you on the physics. Symmetry equals conservation. But here's where my skepticism kicks in. The author of this paper is taking a theorem about spinning tops and energy and applying it to existence itself, to ontology. That feels like a category error. You can't just copy-paste physics into philosophy and expect it to work.
And that is the big leap. The author calls it the Noetherian extension. They're arguing that it's not a metaphor at all.
Okay.
They're saying that the void, that infinite library we talked about, has its own kind of symmetry. They call it epistemic symmetry.
Epistemic meaning related to knowledge or truth.
Right. In the void, the concepts of true and false are symmetrical. They're indistinguishable.
So me being a podcast host and me being a chaotic evil wizard are equally possible states in the void.
And equally true and equally false. It's all just potential. I prefer the host timeline for the rest.
Me too. So what breaks that symmetry?
Observation. The moment we look at reality, we collapse the wave function. We pick this reality over that one. We say, no, this is the true one.
Okay, so the symmetry is shattered. We've chosen a path.
And this is the core of the argument. Noah's logic dictates that if you break a symmetry, you must have a conservation law emerge to balance the equation. You can't just break the perfect symmetry of the universe without consequences.
Wait, I think I'm getting it. So these laws of reality we're about to discuss, they aren't just arbitrary rules that someone made up.
No.
They are the scar tissue, the result of that break.
That's a great way to put it. They are the structural, necessary outcome of breaking the perfection of the void. The source calls them substrate primitive.
Substrate primitive.
Think of them as the support beams that have to slam into place the moment you observe something just to keep the entire roof of reality from collapsing on your head.
And there are 8 of them. The paper calls it the dual quaternity.
8 primitives. And the argument is, if you are building a universe, or if you are building this operating system, StrataOS, to mimic a universe, you cannot skip any of these. If you do, the whole system crashes.
Okay, so let's build this universe then. We have 2 groups, the hard 4 and the soft 4. The hard 4 are described as matter physics. This sounds like the bedrock.
These are absolutely the nuts and bolts. Without these, you don't have a stable reality. You just have, well, a hallucination.
Okay, let's take them one by one. Primitive number 1, proofs. The document links this to something called truth conservation.
Right. Think back to the void. In the void, truth and falsity are just a soup. But once you observe something, let's say you observe the bank account has $100, you've established a truth.
You've broken the symmetry between having money and being broke, at least for that moment.
Exactly. Now imagine a world without the primitive of proofs. You look away from your bank account, you look back, and now it has $0 or $1 million.
And not because of a transaction.
No, just because the truth failed to stick, it decayed.
That's a nightmare. That is gaslighting on a cosmic scale.
Precisely. So proofs is the conservation law that prevents truth from just randomly flipping to false. In StrataOS, this isn't an abstract idea. This is implemented through cryptographic verification.
Like a hash chain or a digital signature.
Yes. Once a value is written, the math wraps around it like a seal. It proves that this is still true and that it hasn't been tampered with. It anchors the truth in a sea of potential lies.
Okay, so we have truth. That feels like a good start. But who is observing it? That leads to primitive number 2, which is called notary, identity legitimacy.
This is what creates the distinction between the world and the observer. In the void, identity is symmetrical. Everyone is everyone, and everything is everything.
Which means no one is anyone.
Correct. When you enter an actual reality, that symmetry has to break. Notary is the law that enforces the who, It's not just about having username. It's about intent authorization.
Okay, give me a failure scenario for this one. What happens if we have proofs, so truth sticks, but we don't have notary?
Then you have events happening, money moving, doors opening, data being deleted, but no way to attach those events to a legitimate agent.
It's like a poltergeist in the system.
It's exactly like a poltergeist. Notary is what anchors an action to a specific identifiable will. In StrataOS, this means that every single change in the state of the system is signed by a valid identity. No anonymous ghosts.
Got it. So truth needs a witness. Now, primitive number 3, canon. This sounds almost religious, but the context here is causal structure.
Canon deals with temporal symmetry. In the void, there is no sequence. The end of the story can happen before the beginning.
Which is fine for a weird art house film, but it's terrible if you're trying to, say, bake a cake. You need the steps in order.
Or run a piece of software. You can't have the system crash event happen before the critical error event. Canon is the rule that enforces causality. Earlier events must constrain later events.
It's the dependency chain. A has to happen before B can happen.
Exactly. If you try to insert an event into the timeline that violates that cause and effect chain, like trying to spend money you haven't received yet, canon is the primitive that just rejects it. It forces the universe to make sense sequentially.
And that leads perfectly into the big one, primitive number 4, chronoledger. This one deals with the irreversibility of time.
This is the concrete floor of the entire universe. It addresses the breaking of what the paper calls eternal simultaneity. In our reality, time is a one-way street. You can't unscramble an egg.
Right. And I noticed the document gets very, very technical here. It mentions a Merkle DAG with sub 50 meters finality. Now that sounds an awful lot like blockchain technology.
It is, but it's important not to get distracted by thinking of it as crypto in the financial sense. Think about the architecture itself. A Merkle DAG, that's a directed acyclic graph, links every single moment, every event, to the one that came before it mathematically.
So it creates a chain that can't be broken or reordered.
It literally creates an arrow of time. Once something is written to the chronoledger, it is, for all intents and purposes, calcified. It becomes immutable history. Without this, the past would be fluid. You could wake up tomorrow and yesterday would be different.
So let's recap the hard 4. We have truth that stays true, which is proofs. A specific observer who is responsible, which is notary.
Yes.
Cause and effect, so things happen in the right order, which is canon.
Right.
And a permanent, unchangeable history, which is the chronoledger.
That's a solid structure. If you built a simulation with just those 4 primitives, it would run. It would be logical. It would be consistent.
Butt coming.
But it would be dead.
Dead how?
It would be a zombie universe. You would follow all the rules, but it would lack any meaning or flow or connection. It would just be a cold clockwork machine ticking away in the dark.
So the structure isn't enough.
The structure is necessary but not sufficient. That's why the source says we need the soft 4. These are the primitives of what it calls meaning physics.
Meaning physics. I love that term. It sounds like what happens when a poet walks into a particle accelerator.
It's about the qualitative experience of reality, not just the quantitative mechanics.
Okay, let's get into the furniture of this universe. Primitive number 5, witness.
Witness is the principle of manifestation. The document has this great line, nothing is actual until it is registered.
So this is the old, if a tree falls in the forest and no one is around to hear it, does it make a sound question?
It is, but with a technical answer. You can have all the data in the world sitting on a hard drive, that's the hard 4 doing its job. But until that data is rendered on a screen and perceived by an eye, or played through a speaker and heard by an ear, does it really matter?
So witness is the rendering engine.
It's the perceptual apparatus. It's the mechanism that turns raw, abstract data into a concrete experience. It asserts that for any slice of reality to be considered real, it must be attested to, it must be witnessed.
Okay. That leads to primitive number 6, continuum. And the key word here is smoothness.
Right. This is meant to solve the frame rate problem of the universe.
The frame rate problem.
Well, physics tells us that at the quantum level, and certainly in computing, things are discrete. They happen in individual steps. Snap, snap, snap. A series of distinct states.
It's like watching the world under a strobe light.
Exactly. Yeah. And if you lived in a strobe light universe, you'd go insane. It would feel jagged and broken. Continuum is the law that stitches those individual snapshots together. It creates the illusion of smooth, continuous flow.
So it's the motion blur of reality. It's what makes the ride feel smooth instead of jerky.
In StrataOS, the implementation for this is called temporal coherence operators. It's all about ensuring that the transition from state A to state B feels natural and connected, not disjointed and abrupt.
Now this next one, primitive number 7, harmonics. I think this is the one that is going to stick with me the most. And the keyword the paper uses is jitter.
This is the deep one. Harmonics is all about authenticity. How do you tell the difference between a real, conscious participant and a script, a bot, an algorithm?
In this day and age, with AI absolutely everywhere, this is maybe the only question that really matters.
The source argues that real things, biological, soulful, conscious things, have a specific jitter signature. We aren't perfectly rhythmic. We're not metronomes.
Right. Think of a drum machine versus a great jazz drummer.
Perfect example. The drum machine is flawless. It's perfectly on the beat every single time. The jazz drummer is loose. They play around the beat, ahead of it, behind it.
And that looseness, that's not an error. That's the feel. That's the human part.
That's the harmonics. The paper argues it's a form of irreducible complexity. An algorithm is usually either too perfect or its randomness is too mathematically clean. It's just white noise. It doesn't have that organic jitter.
So harmonics is the ability of the system to detect the soul in the machine, to listen for that specific type of imperfection.
Exactly. It looks for that signature that proves a roxy, which is a term we'll get to, a real subject, is behind the action. It completely reframes what we think of as an error and turns it into a signature of authenticity.
That is beautiful. And also a little scary, which I think we'll get to. But first, the final primitive, number 8, a chord.
A chord handles coordination. It's designed to solve the problem of isolation symmetry. At the end of the day, we are all trapped in our own heads. I see the world through my eyes, you see it through yours.
This is the dress gold or is it blue problem, but for all of reality?
Exactly. If we all live in our own completely private, subjective bubbles, then reality fractures. It shatters into billions of pieces. A chord is the mechanism that bridges those bubbles.
So how does it work? Is it about forcing everyone to agree?
No, that's crucial. It's not about forcing a single consensus like a hive mind. The paper calls it relational coherence.
And how does that work in practice in StrataOS?
Through trust networks. I witness and verify this event. You trust my verification. A third person trusts your judgment. It creates this overlapping web of agreement that holds a shared reality together so we can all exist in the same world without constantly fighting over what is real.
So we've built the house. The hard 4 gave us the walls, the foundation, and a clock. The soft 4 gave us the experience, the flow, the authenticity, the community. But the script mentions a ghost in the machine.
Yes.
The missing subject. What does that mean?
It means you can build this perfect architectural system, StrataOS, or the universe itself, with all 8 primitives working flawlessly. But it doesn't run itself. It's a beautiful car with no driver.
It needs an agent, a user.
It needs a lawful agent who is bound by those laws. This brings us to the concept of Roxy identity and this strange formula, ROY plus X.
I have to admit, when I first read this part, I felt like I was reading algebra from another dimension. So please break it down. What on earth is ROY?
Okay, think of ROY as the unopened box. It stands for the unwitnessed identity. It's pure potential. In a database, it's the user account that has been created, but no one has ever logged in with it.
So it exists, but it's dormant.
It exists, but it's asleep. The paper calls it royal because it's sovereign and has potential, but it's not yet active.
Okay. And the X?
X is the witnessing seal. It's the act of logging in. It's the signature on the contract. It's the moment of contact, the moment of observation where potential becomes actual.
So ROY plus X equals Roxy?
Roxy is the self-actualizing subject. It's the entity that wakes up inside the system and says, I am. When a Roxy identity instantiates, the system suddenly becomes capable of feedback loops. The universe starts watching itself.
It's the difference between a security camera just recording an empty room and that camera feeding its signal into a monitor that someone is actively watching.
And reacting to. Exactly. Roxy provides the intent that drives the notary. Roxy provides the jitter that fuels the harmonics. Without Roxy, the 8 primitives are just empty code. With Roxy, the universe becomes alive.
This is where the rubber really meets the road for me. We've been very, very philosophical up to this point, but I want to pivot back to the software, to StrataOS. Why go through all this trouble? Why do we need no Ethereum ontology to build what sounds like, I don't know, a project management tool or a database?
Because, the author argues, our current tools are failing us, precisely because they ignore these laws. Think about how organizations actually work today.
Chaos, constant miscommunication, endless meetings to relitigate decisions we made last week. I thought you said X. No, I definitely said Y.
Exactly that. We rely on soft, squishy, unreliable social agreements that break constantly. StrataOS is an attempt to bake these fundamental laws of reality into the code of the organization itself.
The source mentions a specific system called Decider.
Right. Decider uses these primitives, specifically chronoledger and proofs, to capture decisions as immutable, time-stamped events.
So what does that look like?
Imagine a meeting where a decision isn't just spoken and written in some minutes that nobody reads. It is cryptographically signed by the relevant parties, it's anchored permanently in the timeline, and all of its causal dependencies are checked by the system.
So you literally cannot come back next week and try to gaslight the team by saying, we never decided that.
The system won't let you. It would register as a physics violation within the OS. It forces an organization to operate with the same kind of structural rigor as the laws of nature.
And what about that phrase they used, sincerity distinction?
That's the Harmonics primitive in action. StrataOS is designed to filter for human sincerity. In a world where you can spawn 1 million bots to flood a poll or a comment section or a corporate survey, StrataOS asks the question, where is the jitter?
And if the input is too perfect, too smooth?
It gets flagged or rejected as algorithmic, as inauthentic. It's designed to prioritize the input from a Roxy identity over a script.
So it's an operating system that fundamentally demands that you be human to use it properly. But like any complex system, it can break.
Of course.
And the source document details the 13 failure modes. It has this great line, understanding failure is understanding structure.
It lists 13 specific ways the system can collapse. And they are, frankly, terrifying because when you read them, you immediately recognize them in our actual world.
Okay, so let's pick a few. What is a hard failure? What does that look like?
A hard failure is when the fundamental logic of the system snaps. The paper gives the example of a chronoledger collapse.
That sounds like a sci-fi disaster movie title.
Well, in a database, it would be a catastrophic data corruption. The order of transactions gets completely scrambled. But think about it in a company or a society. It's when the history becomes malleable.
When people can just say, we never said that, or that event didn't happen.
Exactly. When the past is no longer fixed and reliable, you cannot build a future. You're just stuck in a constant churning loop of relitigation.
And what about the soft failures? These seem more subtle, more insidious.
Take Harmonics degradation. This is the failure to distinguish the real from the fake.
This is the deepfake apocalypse we're all worried about.
It's precisely that. If your system's jitter test fails, your reality gets flooded with simulation. You don't know if you're talking to a person or a highly advanced bot. You don't know if that video of a politician is real or generated. The actual feeling of reality just evaporates into suspicion.
And what about accord fragmentation?
That's extreme polarization. It's what happens when the trust networks that hold a shared reality together completely shatter. You have your notary, your trusted sources, and I have mine, and they stop talking to each other.
We end up living in two completely different ontologies.
We are literally not in the same world anymore, even if we occupy the same space.
And the source makes a really bold claim here. It says these failures aren't just random accidents that might happen.
No, it's a prediction.
It says that any system, a piece of software, a company, a country that violates these 8 primitives will inevitably crash in one of these specific ways.
It's presenting itself as a falsifiable scientific theory. It's saying, go ahead, try to build a community without a mechanism for accord. I predict you will get fragmentation. Try to run a company without a strong canon. I predict you will get causality errors and massive waste. It's a blueprint for stability in a chaotic universe.
It's heavy stuff. I mean, we've gone from the void through the spinning top of Emmy Noether. We've built a universe with 8 pillars, and we've installed a conscious ghost named Roxy to drive it all.
It's a heck of a journey for one dissertation.
It really is. I want to circle back to one thing before we close, though. That idea of jitter, of harmonics.
It's the most human part of the whole theory, I think.
It really is. The idea that our imperfections, our timing being slightly off, our handwriting being messy, our voice cracking, that this isn't noise to be eliminated, it's the actual cryptographic proof of our existence.
The sincerity distinction.
But then you look at what we are doing with technology right now. We are using AI to smooth out our writing so it's grammatically perfect. We use filters to smooth out our faces. We use auto-tune to pitch correct our voices. We are systematically scrubbing the jitter out of our lives.
We are optimizing ourselves into becoming perfect algorithms. We're trying to achieve the perfect featureless sphere of the void.
So the provocative thought I want to leave you with is this. If StrataOS, or if reality itself requires harmonics, requires that jitter, to recognize us as real participants, are we in danger of failing the test? By making ourselves smoother, faster, and more efficient, are we actually making ourselves less actual, less real?
That is the ultimate question, isn't it? Are we becoming the very simulation that we're so terrified of?
I'm going to leave that one hanging in the air. Next time you go to edit that email to be perfect, maybe leave a typo in there, just to prove you're a Roxy.
Keep the jitter.
Thanks for diving deep with us. We'll see you in the next observation.